M1 Kinematics Example 8. This is quite a long example, so we're getting into more the sort of thing that you might get asked to do on an exam paper here. So we've got a particle moving in a straight line. It's got a constant deceleration. Now, deceleration means it's slowing down, so we make it a negative. At time t equals 0, the particle passes through a point O with speed 13. So that's our initial speed. And we're travelling towards a point A where O to A is 20 metres. So that's going to be our, A is going to be our finishing point. We've got to find the times, plural, where the particle passes through A. So if you imagine that we're going along from O to A, and even from the beginning, the particle is slowing down. At some point, it will pass through A, and then because we've got a negative acceleration, eventually the particle will come to rest. And then because it's got a deceleration in the direction OA, what would actually happen is it would come to rest somewhere over to the right of A, and then it would actually start moving back in the direction of O, because we've got a negative acceleration in the direction OA. In other words, it's wanting to move backwards towards O. So we're actually going to get probably 2 times where it passes through A once in each direction. So let's have a look. Thinking about what we want T, we want A, we've got A, we've got U, we've got S. So thinking about an equation that involves all of those, okay, so S is 20, U is 13, T we're not sure of, and then we've got a half, A is -4, T squared. So if we just simplify that, we're going to get 20 equals 13t, half of -4 is -2, so -2t squared. Now you can see that's a quadratic equation, so I'm going to rearrange it. And I'm going to bring it over onto the left-hand side, because that makes the t squared positive, and I know that will make it easier to factorise. If indeed it does factorise, it might be we need to use the quadratic formula. So having a quick look at this quadratic, I think it actually does factorise. 2t and t at the beginning, and then I think 5 and 4 -8 -5 is -13 plus 20. So working it out, the first one will give us 5/2 for t, and the second one will give us 4. 5/2 is 2.5. So what's happening is the particle's moving past A at 2.5 seconds. It comes momentarily, instantaneously to rest. Then it passes back there through A at 4 seconds. Okay, we've got to find the velocities of the particle when it passes through A. So at these 2 particular points, that's relatively straightforward because we've got U is 13. We know the 2 times. We know that A is -4. So T is either going to be 2.5 or 4. And so because we want to know the velocity at those times, we'd use V equals U plus AT. So it's really straightforward. V equals U plus A is -4. And the first time was 2.5. So if you work that out, that works out to be 3. So when it's going through A for the first time, it's going through with a speed of 3 meters per second. If we use the same equation, but this time with 4 seconds, because that's the second time it goes through at 4 seconds, we get an answer of -3. What that means is that it's still going through at 3, so it's come through, it's come to rest, coming back again through A, and it goes through again at 3 meters per second, but it's in the opposite direction to the direction that we started in. So the initial velocity was 13 from left to right. So what that tells us, this -3, is that we're now moving from right to left, we're going backwards. So the negative sign indicates the direction. Part C, we've got to find the value of t when the particle returns to the starting point. Okay, so if it's gone along and come back to where it started from, although it's actually travelled some distance, the displacement from the starting point, which is what S actually measures, is 0. So S is a measure of displacement from the starting point. So if we're asking when it gets back to the starting point, the actual displacement is therefore 0. That doesn't mean it hasn't gone anywhere. It's gone somewhere and come back, but in relation to the starting point, it's currently in a position where it's back where it started from. We know our initial velocity was 13, and we know that A is minus 4. We want to know the times when it's at the origin. So we're going to use S equals ut plus a half at squared. Again, S is 0, u is 13, t we don't know, a half, a was minus 4, and we've got t squared. Simplifying that like we did earlier, half of minus 4 is minus 2. This is a quadratic. It's one of those where we've got a t in both terms. So we take t out as a factor. And so this gives us two solutions. We've either got t equals 0 or 13 minus 2t equals 0. And solving this second one will give us that t is 13 over 2, which is 6.5 seconds. That tells us that it started off at this particular point, O, at 0 seconds, and it gets back there at 6.5 seconds.